Okay, so let me
Great.
start then.
Yeah. No, I think let's wait for a couple of minutes.
All right.
I think people will slowly be joining
Joining.
us. Yeah.
Sure.
Yeah. Do you want to take the questions at the end of the session, or you answer them as you get them?
Um, I think so. The best will be on the end of the session, but
Perfect.
you can
Perfect.
interrupt me anywhere and
Sure.
anytime you want. So no worries from my side. I have three screens, so I should see the questions in the feed. So
Yeah. Okay. Okay. I think we can get started. Okay.
okay, perfect.
Hey, folks. Good afternoon. I hope you had a good lunch. We are going to start this session on CI/CD for AWS Lambda functions, and with me is Pawel. Let me introduce
Hey.
Pawel before we move in to the session itself. So Pawel is a lead systems engineer at EPAM Systems. His main focus is on being a solution architect slash delivery manager, and he's proficient with the end-to-end delivery, architecture design, and leading the DevOps team. Today, we're going to talk about CI/CD using AWS Lambda functions. And just to give an introduction, CI/CD generally refers to the continuous integration, continuous delivery, or deployment term used in making sure the development and the operations go hand in hand while building applications. And AWS Lambda is the Amazon Web Services event-driven serverless computing platform, and the platform supports Python among others like Java, Go, etc. Over to you, Pavel.
Yep. Thank you very much for your introduction. Yes, exactly. So AWS Lambda can support Python very well and even better than other different languages, except Node.js, I believe, still. Right. So today we will talk about mainly AWS resources, AWS services, etc., etc. The only one thing which will be not AWS is, well, Python. I prepared for today's session a very small, very, from your perspective, very stupid Lambda function, Lambda code of the Python function. The purpose of this function is only just to do some mathematical exercises with two numbers, and that's it. But I strongly believe for the presentation, for the topic is definitely enough. So yeah, let's get started then. My name is Piwosz, as you heard already. I'm working at EPAM Systems as a lead system engineer. Also leading the DevOps community Poland. Small community right now, like a sleepy one, but I hope we will grow very soon. Also, I'm DevOps Institute ambassador, where we are focusing on human side of DevOps. Excuse me. So agenda for today is very simple. We will use CI/CD in order to deploy AWS Lambda using AWS SAM. What is SAM? I will tell you in a couple of minutes. And everything will be built using AWS CloudFormation. This CloudFormation template will build for us the CodePipeline, which is the CI/CD tool from AWS. On the end, on the middle, we will have some demo. I will show you how to work with this and what we can expect. Right. So first of all, CI/CD starts in the code. Really, starts even in your head. The proper approach, we can think about CI/CD not only about like a tool set, but also the approach to everything what we are doing, how we designing our approach to the code, how we want to integrate this code with code base, right? But to be on the same page for all of us, let me just give you a short introduction to each element we will talk about. So what we can tell about CI/CD, like it was mentioned in my on the beginning of this session, CI/CD stands for continuous integration / continuous delivery or deployment. So continuous integration, next step continuous delivery or continuous deployment. Right. So what is continuous integration? This means like a regular commits to your code base. This means also unit test, and it finished on artifact build, really, or artifact build and store it somewhere. So this is the like a boundary for CI, right? Continuous delivery then is automated tests. Automated delivery of those artifacts to the testing environment, and also control what is delivered there. And I'm calling continuous delivery as a one-click deployment. Why? Because continuous delivery has some hard stop in some place between some of your environments where you need to go there manually, do manual tests, do manual approval. So this is this one-click deployment. Click yes, I agree. I can deploy it to the production, for example. Continuous deployment then means one step further. This means automatic installation of your artifacts on production systems. This is like a zero-click deployment. So when you commit your code, finally, without any intervention, it lands on your production system. Very small change, only one click, but everything changed in between, because you need to be really well prepared for this. So let's look on very simple example how we can understand the process for CI, right? So we are starting with the commit. After the commit, we have like a static code analysis. So we can use SonarQube, we can use different tools for it. We also have unit tests there. Of course, unit tests can be run on your local machine when you are in the process of development before you commit the code. But the truth is, it is very good to have this unit test also in CI pipeline. Then we are building the artifact, we are testing this artifact, and we store this artifact somewhere. It can be Artifactory, it can be some, in case of AWS S3 bucket, whatever, right? So this is the place where we are storing what we built during the process of building artifact. So for CD, then, let's take into consideration continuous delivery. We are collecting this artifact from previous step. We are deploying it, for example, to QA. Let's call the first environment QA. We are doing some tests, automatic, manual, whatever. Let's suppose automatic. Then we are deploying our artifact to, after of course the successful tests, we are deploying this artifact to our release candidate environment. Then we have some tests again, manual approval. This is the place where continuous delivery take a place. And deploy to production. It can be manual, it can be automated by after the click or something like that, right? When we remove this step here, we are starting approaching the continuous deployment process. So this is, as I said, again, very small difference, but very big change of the approach. So I'm spent a little bit more time on CI/CD now there, because it's not just like very simple, flow that you have your code, you have your environment, you're just deploying it. It sounds very simple, right? But in fact, CI/CD is a very complicated process, and even you can think about CI/CD in large scale. It's the approach to your code and application for your organization, right? So how to define CI/CD when you are starting, when you are coming to the organization, when you try to build proper process of CI/CD delivery. There are a couple of things you need to take into consideration. So first, let's start with constraints. What can be our constraints? For example, you have closed environment. You cannot use cloud-based services. You need to stay with specific solution, with specific tool. There is a constraint regarding, for example, pull request and reviews, etc., etc., etc. Those things need to be taken into consideration. Next element is branching strategy. If we are using trunk, if we are using Git flow, right? So those are completely different, of course, or even if you want to use something in between, why not? Right? It's your model, not something what someone is using. The best example here is the Spotify model of Agile, right? Everyone to work as a Spotify model of Agile, but Spotify model of Agile will work only for Spotify. That is the truth. Then SDLC, so your life cycle for the application, responsibilities. Who is responsible for merging? Who is responsible for code review? Who is responsible for if you have, for example, change management, right? Next step, deployment strategy. So generally speaking, continuous delivery or continuous deployment, right? Artifact versioning. Do you want it or not? How you store those versions? How you can reuse them, right? Do you build Python packages in pip, or you just deploy everything as a single package to your environment? How you approach to the releases, right? How you want to what kind of tools you want to use for your CI/CD pipeline? Because, for example, CodePipeline will not work that well with multi-branch strategy, like, for example, Jenkins, right? What is your approach to rollbacks? It is automatic. It is manual. What need to be done to roll back your application? Are you using infrastructure as a code into your pipeline? Are you building your pipelines using infrastructure as a code? What quality gates you are using? And how you want to monitor this CI/CD, right? So as you can see, this is really complicated thing. It's not like, okay, I will use Jenkins, done, right? Right, so this is CI/CD, very short introduction. I have longer talks about this, no worries. So maybe one day. Let's go to AWS Lambda. What is AWS Lambda? So Lambda is the AWS approach to serverless. What means serverless in this case? That you don't care about anything else than code, more or less, honestly speaking. So this is the AWS compute service, one of the compute service. They claimed it runs your code without provisioning and managing servers, and that is true. But honestly speaking, you still need to care about some underlying resources like memory, like execution time. This is not a resource, but you need to think about this. Also, even if AWS claims Lambda is automatically scalable, you still need to care about this, because you have hard limits for your concurrent Lambda executions, and with very big application, you need to take care about the concurrency of your Lambda to not just drain your limits, right? This is pay-as-you-go model. So you are paying only what you are executing. So generally speaking, if your code is executed, then you are paying. You are paying for the execution time and memory used. So this is those are two elements you are need to consider here. Lambda supports many languages like Python, like .NET Core, like Node.js, etc., Java, etc. And if there is no proper runtime for you, you can still use your custom one. The news from AWS, you can even run Docker containers as a Lambda function. So this is like a publicly available from currently running reInvent event. For monitoring, Lambda functions are very well construct because you can use a couple of tools here like CloudWatch. This is default. X-Ray, which allows you to trace everything what's going on inside. And Lambda Insights, which is kind of news again, announced like last week, last month, something like this. Very useful tool, very helpful for analyzing your performance, etc., etc. Do we have any issues with Lambdas? Unfortunately, yes. Maybe you heard about the most crucial one. It is called cold start. What means cold start? Cold start means when you invoke your function, this function needs to build some underlying resources. So imagine that you want to execute your Python script or Python application, but your application also need to have some dependencies, some external dependencies which need to be download, executed, etc., etc., etc. This is some time needed for AWS to prepare your runtime, prepare your base to actually execute your code inside. And this is very visible for precompiled languages like .NET and Java. For example, for .NET at this moment, with almost all improvements you can apply there, the cold start take like 600 milliseconds, more or less, around half a second. For Python, Node.js, so interpret languages, it's definitely faster. So it shouldn't be longer than dozen milliseconds. So it's definitely faster. How to observe this? How to understand this cold start from your as a developer perspective? So we can use Lambda Insights. So using this, you will know how many invocations suffers really from cold starts, and also X-Ray, which can show you exactly how long it takes to Lambda to start after cold start. So let's look on the invocation itself. It looks like this. So you have cold start. This is long cold start. Then you have execution. This is example, for .NET. For Python, it will look like this. And when your Lambda is warm, so it means that some request already started this Lambda, and Lambda can stay warm for you like for 15 minutes, if I remember correctly. It will look like this. There is no cold start needed, no preparation needed. Also, you need to remember that the difference between Lambda and Docker, very important difference, is that Lambda is able to execute only one request in the time. So if you send two concurrent requests and you have one Lambda warm, one request will hit this warm Lambda and be executed faster. Second, need to spin up new Lambda. So this is a very important concept here. Right. I hope. Yes, exactly. So Rami, you are right. So cold start is a kind of minimum setup time to run the request. Yes. Right. So what is the SAM model? SAM model is AWS approach to serverless, and this is abbreviation. It means serverless application model. Right. This is the open source framework from AWS. This is in fact CloudFormation extension. So you are building a template. When you execute this template, it creates a CloudFormation stack which is executed on AWS. It is optimized for serverless, obviously. It organizes related components and resources for you. So, for example, you can say in the template of SAM model that your Lambda function needs API, and this API will be created for you. And it allows you to local debug and test of your code using Docker. You have to have Docker installed on your local machine to test it. How the template itself looks. So this is the example of the template. This template will be used by us in our demo. What we have here, a couple of elements. We see that the most important element here is the resource section. We are creating Lambda function, which has the logical name Lambda function. Well, we said what is our handler. Handler means for AWS Lambda to execute your code. It needs to have this handler to the function which need to be executed as first. Right? We are saying code URI, where is the code of the Lambda to be deployed, what is the runtime, alias is the versioning approach for AWS. So you are deploying this Lambda function with the alias live. Description is obvious. Then we have memory size for our Lambda function, timeout, after which Lambda will throw error, and then we have events. Events in our case say that we want to create simple API. This is again logical name with just a standard path, root path with method get. That's it. Very simple and honestly speaking, very powerful thing. As I mentioned, this is the CloudFormation really template. This is the template built based on CloudFormation, and when you execute this SAM model, it will be translated to the proper CloudFormation template with all resources like IAM roles, policies, proper events, APIs, etc., etc., etc. So CloudFormation. What is CloudFormation? Probably all of you are familiar with infrastructure as a code, with Terraform. For AWS, they have their own native tool called CloudFormation. So what is the concept of CloudFormation? Of course, it creates infrastructure from code, from templates, right? Thanks to this, you can keep your infrastructure, yes, in your version control tool, right? And you can control your infrastructure against templates. CloudFormation call it drift. So you can check periodically if your existing actual infrastructure is really well described by your template, if there are changes or not, right? A very important concept of CloudFormation, which we will use today, is ChangeSet. What is ChangeSet? ChangeSet allows you to work with CloudFormation templates in the CI/CD way. So you can create your artifact, you are creating your ChangeSet, and then you are executing your artifact, executing the ChangeSet. In meantime, you can automatically or manually check the differences, the updates, right? So for ChangeSet create, you are creating something what can be called a changelog between existing executed template and your prepared template on your machine. This is perfect tool for approval step, because the ChangeSet is showing you what will change and how and why. By this, you also can create a changelog for version control. So you can version your infrastructure with proper description of it. Then we can execute our ChangeSet. This means that we are applying changes to the existing stack. And in case of error, we are reverting them. The problem here is that ChangeSets can be failed for 3 reasons. First of all, if the ChangeSet will fail if there is the if there is ChangeSet already prepared and not executed with the same name, so you cannot create two ChangeSets with the same name, the ChangeSet will fail where there is no change in the template, and obviously ChangeSet will fail if there is an error in the template. Right? Okay, so this is CloudFormation, which we will use. Now let's go to the clue of our approach to CI/CD, AWS CodePipeline. CodePipeline is let's say orchestrator for all CI/CD blocks which you can find on AWS. So it contains a couple of components. So first, CodeCommit, CodeArtifact, CodeBuild, CodeDeploy, and CodePipeline itself. So kind of recursive here, but that is true. So let's go one by one in a couple of words. So what is CodeCommit? This is a version control service. It's fully managed. Very important is that AWS claims it's HAPAA compliant. So this is this medical compliance from US. Right? Very, let's say, the highest if you are thinking about the guarantee of the security of your data, etc., etc., etc. Works with standard Git and integrated very well with other AWS services. So just Git, so your code base repositories. CodeArtifact, quite new for AWS. It's fully managed artifact repository, so you can use it as a similar thing like Artifactory. Currently, you can use Maven, Gradle, NPM, Yarn, pip, which is important for us, Twine or NuGets. NuGets are pretty new, like last week or something like that, and nothing else, unfortunately. It is integrated very well with other AWS services, and also you can use it as an external service for your external tools, for example, for Jenkins. So this is the artifacts. We will not use it today. CodeBuild, we will use it twice, really. So fully managed CI tools. It's on demand, so it scales when you need it. It contains a couple of pre-built or pre-configured environments for you. Customization is possible, like with other tools, of course, so you can install everything there, etc., etc., etc. It has reporting capabilities, quite new this year, was introduced by AWS, and very often it is used to create deployment jobs, really, because it's easier than using CodeDeploy. CodeDeploy is fully managed deployment service. And it can deploy multiple application contents. By this, I mean not only where it can be deployed, for example, containers or ECS, EKS, which are container platform for AWS, but also Lambdas. But I mean, what is the source here? So it can work with CloudFormation, it can work with some templates, we can work with executables. So very, very, very big scope here. It has very good integration with container services and Lambdas, so it can help with canaries and blue-green deployment like out of the box. But honestly speaking, it's quite complicated if you want to use CodeDeploy in multi-account deployments. So between the different accounts, and even if you are staying in one account, it's still quite not that straightforward, let's say. There's a huge work you need to do with IAM roles, policies, etc., etc., etc. That's why it's very often not used. Example here, if you want to deploy, you have like a CI/CD account and you have your application account. If you want to use a CodeDeploy to deploy your code to this application account, you need to have like a trigger executor on your CI/CD account and full CodeDeploy application on the application account. So kind of you are splitting it in, and you can lose tracking, proper tracking of the configuration. This is the risk. Right, CodePipeline. Again, this is managed service. By AWS, it is described as a continuous delivery tool, not continuous deployment. Integrates all components in functional process. Can be managed by infrastructure as code templates.
Hey, Pavel.
Yep.
Just a gentle reminder. It's been 30 minutes, so
Yes.
just a gentle reminder. Yeah. Thank you.
Yes. Okay. Thank you very much. Now we are going to demo. So very good timing. For demo purposes, if you wish, you can clone this repository to your own clone, fork, whatever, and play with this. We will go through it step by step, and this link will be on the end of the presentation, so no worries here. So what we will do, we will create an example Lambda function with a couple of resources. For Lambda, we will use a SAM model. We will create the Lambda function itself, an API gateway, right? In order to do it, well, of course, the IAM roles and policies as well. In order to do it, we will create pipeline with CodeCommit, CodeBuild, CodeDeploy, CloudWatch event, SNS topic. So this is a simple notification service. And of course, IAM roles and policies. And everything here will be deployed by CloudFormation. So like 2, 4, 6, 7 resources to create something like this. So very simple. So a user is requesting API gateway to have some response from Lambda function. That's it. How our pipeline will look? This is the schema. So based on CloudFormation, we will create CodePipeline, which will have connection to existing CodeCommit, so version control. You can create it also with CloudFormation, but in our case, in our scenario, there is a full scenario in the lab on GitHub, so you can follow it. You need to create CodeCommit first, and we will use the name of this CodeCommit in CodePipeline in order to collect all information here. Unfortunately, when you are building CodeBuild, CodeBuild is not tracking what's going on in CodeCommit. So there is no trigger, no kind of webhook, nothing like that. You need to use something what is called CloudWatch event. CloudWatch event is observing CodeCommit in case of any change. And if there is any change in CodeCommit, it triggers CodeBuild. I hope this is clear for you. So in order to have like an automated start of your pipeline, you need to have CloudWatch event. So CloudWatch event will trigger our pipeline, which will test our code. You run unit test and run code coverage. Then we will build our artifact, and we will go to the deploy, where we will create and execute our ChangeSet. And with CloudFormation SAM model, we will build API and Lambda function. For CodeDeploy, we will have like 3 steps in the deployment process. We will create ChangeSet on the first. Then we will send the information about the manual approval that your change is ready, you can approve it. And for this, we will use SNS topic. And then when the approval will be done, automatically we will execute the ChangeSet, right? Okay, so for the infrastructure as a code, what we need here, we need, of course, AWS CLI, and we need to have CodeCommit repo already prepared. Everything is in the resources in the README, so you can find it there. Infrastructure as a code will create for us the IAM, simple notification service queue topic. It will create the event. It will create the code build for test, code build for build, and code deploy itself. Right. So let's go. Let's go and see what we can do. All right. So this is our AWS console. In our code pipeline, come on. We have our source here, repositories. Yep. And this repository is very simple, contains like this is our Lambda function directory where we have our Lambda function. As you can see, it's very, very, very simple. Then we have our tests here, which are also very, very simple. I create a lot of them in order to show how it looks in the reporting phase. We also have our infrastructure as a code here, which is our template for building our code pipeline. Right, so this is, let's go one by one. So first of all, I'm using two parameters, right? So this is for notification, who should be notified by SNS topic. And there we have repository name to which we want to connect our pipeline, right? We are creating one bucket to store all our artifacts. So CodePipeline itself, CodeBuild, CodeDeploy are building using a lot of artifacts during the process. So every single step can create kind of artifact for you. And also I'm using this to store the template of Lambda function itself. Then we have a couple of roles and policies, so it's not the best time to go through it. And we have our definition of pipeline. Sorry, this is role still. This here. So this is our pipeline here. This is our type, right? And we define stages. It's very similar to other tools, really. So we have first stage, which is called pull source. I'm using the category here to say to AWS Code Pipeline that this is the type of which I want to use. The provider is CodeCommit, can be GitHub, can be Bitbucket, etc. And this is our reference here to the repository name parameter, which you saw on the beginning of this template. So this is the first stage, pulling the source. Second stage is the test and coverage. Very important parameter here, configuration. What it means. As provider, we are using CodeBuild. This means for CodeBuild, by default, you are using the file which is called build spec YAML. This file is contain all commands needed to execute your build phase. You can do it in three ways. You can use just default code build spec or build spec file in your repository, and this will be used by default. You can use the same type of file with different name for different stages, but you need to point this file into your stage, or as I did here, as a configuration project name Lambda test, you can have this here. This is the project. This is the code build project here. And this is my build spec file to this place, right? So we have a couple of phases like install, build, post build, etc. And on the end, we are creating reports. Then we have second build project for the second stage, where we are running this thing. This is how you are executing, how you are deploying your Lambda functions using AWS SAM model. This is our template as our source. We are building the package, which on the end will finish with this output template YAML, which is this actual CloudFormation template. This all will be zipped. So in the zip file, you will have this template and Python code of your function. So it will be combined in one file and be executed by our CloudFormation. Let's go back to this thing. So we discussed this part as well. On the end, we have deployment. On the deployment, we have 3 phases of this stage. So this is stage called deploy Lambda, and we have create ChangeSet, manual approval, and execute ChangeSet. As you can see also, there is run order 1, run order 2, and run order 3. What this means? This means that we will create steps like first, second, third. If I will use run order 1, run order 1, run order 1, I will create like a one stage with 3 elements in one stage. So all of them need to be completed in order to go next to the next one. And the last thing, we have our event here. Oh, this is my mistake. I need to fix it. This event is looking on our repository here, and if there are any changes, it will execute this pipeline. So let's see how the pipeline looks after being created by CloudFormation template. We have our get source. We have second stage with Lambda tests. We have our build artifact. So this is execution of the SAM template, create the package and store it on S3. Then we have the deployment. We are creating ChangeSet. So everything what changed between the 2 stacks. Approve this ChangeSet and then execute this ChangeSet in order to create all changed things in our application. So let's see what our Lambda is returning right now, because I deployed it previously. Come on, faster AWS. Right. So we have our API gateway here. Let me just go inside. We need to go to stages, to production one, and here we have an URL which we can use, right? So as you can see, this is the response from Lambda function. So now what we will do, we will go to our code. So this is our simple function here. And let's do the changes, right? So let it be something like that. Let me save it. Right. And I'm pushing my changes to the repository. Yep, it was changed, I hope, at last. So let's see what our pipeline. Yes, as you can see, our pipeline is executed right now. It takes some time, unfortunately. I believe we have still a couple of minutes, so good. What I want to show you as well here. Yes, so we see our first stage is successful. We can go and see our history of our executions here. Everything what was succeeded or failed, and also why it failed. You can check here. What is not that very nice about CodePipeline, for example, let's wait a couple of seconds to finish this test and coverage here. The whole pipeline takes like between 5 to 10 minutes. So it's let's say quite slow. Let's say this way. So when we go to the details here, as you can see, we switched directly to build process, so to code builds. Here you have the full log, what happened. Every single thing is there. All right. You can see the phase details. There are a couple of phases, as you can see here. And also you can see the reports. Right? So let's see the reports here, what we have. So it's nice that you can see coverage already in the main screen. So this is the code coverage report. As you can see, I have like 56 lines covered and 8 lines not covered. And what file is covered with what coverage. So this is nice. And also I can see the unit test phase with all my executed test with duration, message if there is, etc., etc., etc. This is very nice thing. And also what I can see, I can see the report groups. I'm sorry, report history. For report history, I see all historical reports here. I'm sorry, something is not here. I need to find it because this is where I can see really build history, I believe. No, report history. Anyway, sometimes even I am lost in this console. So what I can see really is to see the details about all executions, and not only all executions, but to see this report here. Right? So I see exactly the execution errors, the time of the execution, etc., 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 etc. Okay, let's go back to our pipeline. It's still in progress. Okay, you see, it's waiting to my approval, and I should have this approval here somewhere. Let me just show you this. Yep. Let me just share my screen here. So you are receiving this kind of email with information what's going on and waiting for your approval, right? So let's go here and do the review. Yeah. I can read about this, and also what I can do as a manual step, I can go to CloudFormation. This is my stack created by some model, right? And if I go to ChangeSets, this is my ChangeSet created by my CodePipeline. And I can see here, okay, so alias is changed, code version is changed. Right, sounds good. It will remove this old Lambda, create new one. Perfect. Let's approve this. We are going to the next stage. This ChangeSet right now is executed. Yes, there is no ChangeSet. As you can see, we are updating our stack. Yep, we changed everything, and now when I if I go to my API and change, yep, the changes are there. What is the power of the SAM model here as well? It helps us to really deploy the code. This is the issue with very often with CloudFormation and Lambda functions. So if you are deploying your Lambda functions with just simple CloudFormation and you store your Lambda function code as a zip file in S3 bucket, if you execute your CloudFormation, it will not update your code. You need to use some model for it, because CloudFormation just check there is a zip. Yes, there is. The name, everything is the same like it was. Yes, no updates, right? Some model is really actually updating the code of the Lambda function. Right, I believe that's all here for this this presentation at this moment. If you like to copy this repository, please do. There is a good README for it. You can play with this. You can create everything by yourself. Only two things you need to create by yourself, not by the automation, is the CodeCommit repository and your proper configuration of Git. All instructions are there, so you can go there and do and play. If you wish to stay with touch with me, please, I'm open for new friends everywhere. If you have any questions, please ask me. I'll try to do my best to answer you. And yeah, that's it. If you have questions now, please, I also try to answer. So thank you very much for your time. I hope it was useful for you.
Folks, any questions? You can either post them in Q&A or raise your hand to speak. Thanks a lot, Pawel. That was really informative.
I hope so. I hope so. So it's only 1 hour, so there's no possibility to go deeper in everything. But as I said, please contact me if you need, if you wish, if you like. I will answer to all your questions, I hope, regarding this topic, and help you to use this approach in your work, in your life. Wow, that sounds bold, but yeah. Thank you very much, guys, for your time, and I hope you will enjoy the rest of the conference.
Yeah. So if you have no questions for Pawel, I think Pawel, there is a lounge section in AirMeet. Maybe if anyone wants to talk to Pawel, you could go to the lounge section.
Yep.
Thanks, guys.
Thank you very much.